Have you ever wondered why a whiteboard marker glides across that smooth surface and wipes away without leaving a trace? We're diving into the fascinating world of whiteboard manufacturing, from the moment steel or plastic substrates are prepared to when they're coated with porcelain enamel or melamine, the special layer that makes dry erase possible. You'll discover how these classroom staples evolved from dusty chalkboards and learn about innovations making whiteboards more sustainable.
Welcome to Goalie's Pip Academy.
What is whiteboard manufacturing? At its core, it's the industrial process of bonding ultra-smooth, non-porous coatings to rigid substrates to create erasable writing surfaces. If a chalkboard is paper you write on with charcoal, a whiteboard is a mirror you write on with ink that refuses to stick. The magic isn't in what you add, it's in what you prevent from happening. Let's rewind about 70 years. It's the 1950s. Classrooms are filled with chalkboards and chalk dust everywhere. Teachers are coughing. Students with asthma are struggling. Then a photographer named Martin Height experiments with a glossy, enameled steel panel and a grease pencil. It works, but the marks are hard to remove. The breakthrough comes when someone pairs these smooth surfaces with a new kind of marker, using a volatile solvent and polymer-based pigment. When you write on a non-porous surface with this marker, the solvent evaporates instantly, leaving behind a thin film of pigment held together by polymer resin. The coating is so smooth and non-reactive that the pigment never bonds to it. The polymer just sits on top, like tape with weak adhesive. When you wipe it, the dried ink fractures and lifts away cleanly. The secret isn't simply making the surface slippery. It's about engineering the surface at a molecular level. Porcelain enamel, one of the most common whiteboard coatings, is essentially powdered glass fused to steel at over 800 degrees Celsius. The result is a surface harder than most metals, with a microstructure so uniform that there are virtually no pores for ink to seep into. Melamine, the other popular coating, is a thermosetting plastic that creates a similarly dense, smooth finish. Both materials have extremely low surface energy. That means liquids, including the oils and resins in dry erase markers, bead up instead of spreading out. Let's pause for a second. What special coating is applied to whiteboards that allows dry erase markers to wipe away cleanly without leaving residue? Option A, acrylic paint. Option B, porcelain enamel or melamine. Option C, plastic laminate. Or option D, rubber coating. The correct answer is B, porcelain enamel or melamine. Porcelain enamel is technically a type of glass, which is why high-quality porcelain whiteboards can last 30 years or more without degrading. Cheaper melamine boards can start to stain and ghost after just a few years because the plastic coating is softer and more porous.
Hey! You're watching Goalie's Pip Academy, where we teach about science, geography, history, everything about the whole world. If you want to watch these classes with no ads, no distractions, go to getgoalie.com.
Now let's walk through how these boards are actually made. It starts with the substrate. For premium boards, manufacturers use cold-rolled steel sheets, typically between 0.4 and 0.6 millimeters thick. Why steel? Because it's rigid, magnetic, and can withstand the extreme heat needed for porcelain enameling. The steel arrives in massive coils and is cut into panels. Once the ground coat is complete, the cover coat is applied. This is the glossy white surface you actually write on. It's another layer of powdered enamel, formulated for maximum smoothness and whiteness. The panel goes back into the furnace. The glass melts again. And when it cools, you have a surface that's scratch-resistant, fireproof, bacteria-resistant, and capable of being cleaned with harsh chemicals without degrading. Not all whiteboards are steel. For lightweight or portable boards, manufacturers use a plastic substrate, usually high-density fiberboard or a honeycomb polymer core. These boards are coated with melamine resin. The melamine is applied as a thin film under heat and pressure, kind of like laminating a document at industrial scale. The process is faster and cheaper than enameling, which is why melamine boards dominate the consumer market. But the trade-off is durability. After coating, every board goes through quality testing. Manufacturers check for pinholes, surface imperfections, color consistency, and erasability. One common test involves writing on the board with a dry erase marker, letting it sit for 24 hours, and then erasing it. If there's any ghosting or residue, the board fails. What materials are commonly used as the base substrate in whiteboard manufacturing? Option A, wood and cardboard. Option B, glass and ceramic. Option C, steel or plastic. Or option D, aluminum foil and paper. The correct answer is C, steel or plastic. The substrate determines the board's entire performance profile. A steel core porcelain board can cost 10 times more than a plastic melamine board, but it will also outlast it by decades. The whiteboard industry is undergoing a transformation. For decades, manufacturing whiteboards was resource-intensive. Porcelain enameling requires massive amounts of energy. Steel production has a significant carbon footprint, and traditional melamine resins are derived from formaldehyde. But in the last 10 years, sustainability has become a driving force. Some manufacturers now use recycled steel for substrates, diverting scrap metal from landfills. Others are developing low-temperature enameling processes that cut energy consumption by up to 40%. On the melamine side, companies are formulating eco-friendly resins that eliminate formaldehyde and use bio-based polymers. There's even a movement toward boards made entirely from recycled plastics. One exciting innovation is the rise of glass whiteboards. Glass boards, made from tempered safety glass, are completely non-porous, infinitely recyclable, and they never stain or ghost. They're also frameless, which reduces material waste. The catch? They're expensive and heavy. But as manufacturing scales up and prices drop, glass boards could become the new standard. One final question. Modern whiteboard manufacturers are increasingly using recyclable materials and eco-friendly coatings to reduce environmental impact. Option A, true, or option B, false. The correct answer is A, true. Major manufacturers have published sustainability reports showing measurable reductions in carbon emissions, waste, and hazardous materials. Whiteboard manufacturing is a microcosm of modern industrial challenges. It's about balancing performance with cost, durability with sustainability, tradition with innovation. Every board represents a series of trade-offs, and as we move toward a more environmentally conscious future, the humble whiteboard is evolving from a simple classroom tool into a case study in how industries can reinvent themselves. Next time you walk past a whiteboard, take a closer look. Notice the smoothness of the surface. Think about the steel or plastic underneath. Consider the chemistry that lets you write and erase without a trace.
My mind is blown! Where can I learn more about these videos? Oh yeah, getgoalie.com. There's no ads, there's no junk, just cool stuff for kids and a dedicated tablet. Check it out, getgoalie.com.